Assalamualaikum warahmatullahi wabarakatuh to our panels, Dr. Muhammad Aifah bin Muhammad Arif and also Dr. Muhammad Nur bin Abdullah. My name is Nurul Syuhada binti Musa. My metric number is AE180105. So in this video, I will present my final year project 1, which is the title Implementation of Solar Powered Water Heater Using Copper Pipeline for Expediting Evaporation Rate in Solar Desalination. Okay, so for the project background, okay, because it is involved with the solar desalination system, where solar desalination system is a method to produce fresh water. Okay, fresh water is really important to human needs. Okay, especially to the people that had to find the fresh water. As example, the people who live at the North Africa, Middle East, and also the people at the far away from the source of water. Okay, so solar water desalination is a method, one of the method that can produce water from seawater, brine water, and also saline water. So the focus of solar water heater that I want to propose is as the technology to help the sun, okay, to help the source of suns that transfer heat to increase the temperature of the water itself. Okay, for problem statement, why I want to propose is because water is a limited natural resources. We know that even the industry, residential, and also all types of buildings use water. Okay, because water is not focused on human only, but all the alive creatures. Okay, the other reason why I want to propose this solar water heater is because of the low volume of water production or low efficiency from the current solar desalination system. Okay, for the objective, okay, the first one is to design a standalone photovoltaic PV system that is sufficient to supply electricity to the solar power water heater using copper pipeline. The second objective is to develop solar power water heater. So for the scope of works, okay, the first one is for standalone PV system. Okay, I have to determine the size of PV array, battery bank, and also MPPT charger controller. Okay, for my second scope is to develop the solar power water heater by using copper pipeline. Okay, and then for methodology, okay, for the phase 1 is done for the PXM1 proposal. For phase 2, design and analysis of the water heater, okay, based on the previous research. Phase 3 is experimental setup, which is I have to develop the prototype. And then phase 4 is data collection after I have developed the prototype, and then I have to collect the data required for this project, including the temperature of water and also the time taken that have to be recorded. And then phase 5 is report writing. For the prototype, this is the water heater that I have developed. Okay, the material is copper pipeline 1/4 inches, and then for the wire used is nitrile wire, copper wire, and also the heater socket as the protection of the wire. So as you can see, the last image show the full look of DC water heater design. For calculation, before we proceed to calculate the PV selection, the battery capacity selection, we have to calculate the resistance first. Okay, for the resistance, for the load, we take from the nitrile wire and also copper wire. Okay, so for the total resistance is 3 ohm. Okay, so after we got the resistance, we can calculate the power consumption by use the DC as the voltage as DC power supply 12 volt. Okay, so the power consumption that we get is 48 watt for the solar power water heater. Okay, so for the calculation of the battery capacity, okay, so the battery capacity for the solar power water heater, 48 of watt that we have calculated just now, multiplied by 8 hours that I chose to it to be operate, and then divide by 0.85, 0.6, and also divide by multiply by 12 the DC voltage from power supply, and then the autonomous day is for 1 day, and then the battery capacity that we get is 62.05. Okay, so for the battery capacity, usually we will choose the higher one. Okay, the nearest value, the nearest suitable battery that available is 12 volt 7 ampere hour. Okay, so for the calculation of PV size, okay, before we calculate, okay, we have to know the PV size needed. Okay, so to calculate, we have to multiply by the power and also the hours per day that we use. Okay, multiplied by 1.3. 1.3 is the energy loss in PV system. Okay, so after that we got 499.2 watt hour per day, and then for the PV watt peak required, okay, it is equal to total watt used per day over 3.43. Okay, so the value that we get from the panel's energy need, we divided by 3.43. So the PV watt peak required for solar water heater is 145.54 watt peak. Okay, so the nearest suitable value PV module that are available is 12 volt 110 watt peak. The number of PV panels we need, okay, because the 110 watt peak is not enough for supply our load. Okay, so we have to divide our watt peak, okay, divide by the watt peak available. Okay, so the value we get is 1.32 modules, okay, equals to we take the actual number, which is 2 modules. Okay, so the total PV modules that we need is 2 modules. And then for the charger controller, the calculation is by using the formula total short circuit current of PV array, okay, that our PV module tasked by 1.3. Okay, 1.3 is the value of energy loss in the system. 2 modules that we have calculated just now, tasked by 7.4 ampere. Okay, 7.4 ampere is the short circuit current for 12 volt 110 watt peak PV module that are available. Okay, multiply by the energy loss in the system. Okay, we got 19.24 ampere. Okay, from the current that we get 19.24 ampere, we have to choose the larger one, which is 20 ampere at 12 volt. So that is for the MPPT charger controller. Okay, so for the calculation of energy, heat the 1 kilogram of water. Okay, for the initial temperature is 40 degrees Celsius. For the final temperature is 100 degrees Celsius. So there is specific heat of water, which is 4,200 joule kilo degree Celsius. Okay, kilo degree Celsius. Okay, for calculate the power, okay, as usual, we just voltage square over R, we get 48 watt. Okay, for the difference of the temperature is 60 because 100 minus 40. Okay, for the heat transfer Q, MC delta T. Okay, so just insert in the formula all the value both in the formula, we get 25,200 joule. Okay, from the heat transfer value, we can calculate the time taken. In second, we get 5,250 seconds, and for the time overall, the time taken for water heater to boil the water at 100 degrees Celsius will take 1 hour and 28 minutes. Okay, and then for the prototype testing, okay, so this is the picture where I test the prototype at the panel side. Okay, I connect the prototype directly to the PV panels. Okay, so it's not working because there is a short circuit, and then we detect the short circuit because of the socket itself is a metal. So when the copper wire directly touch the socket, it will cause short circuit. Second testing, I go to the MPRE lab to test my circuit with the DC voltage power supply, which is 12 volt. But still, there is short circuit happen. The LED of the voltage turn red means that there is something short in my connection of water heater. And then we try to figure out what's actually the problem at the connection between nylon wire, copper part line, and also copper wire. To discuss several suggestions and also suggestion for improvement with SP Dr. Sheikh. Okay, so the weaknesses of our my prototype for design, the first design, okay, is the first one is there is no insulator used to wrap the nylon wire. Insulator should be used to avoid directly touch between the nylon wire and also copper part line. Okay, and then for the second weaknesses that we observe is our resistance is very small. Okay, which is before this we calculate our resistance is 0.9. Okay, 0.9 ohm. Okay, so very small. So as we know that the small value of resistance will cause short circuit. So I come up with new design of solar water heater, which is I add the insulator material. Okay, for the other component is still the same, just insert the insulation material for the wire nylon wrapper. So we will wrap the nylon wire with the insulation material. So the copper part line also will be bent, okay, into spring shape. But in this design, I will just show the straight one. Okay, so the improvement is first one, I add insulator material as a wire wrapper. The material of insulator that I choose is magnesium oxide. This is because magnesium oxide has the greater electric insulating qualities, which is 10 to the power of 4 ohm, and also the heat conductivity is also high. Okay, so the figure here show the example how the magnesium oxide will be used to wrap the conductor. Second improvement of the design is we increase the resistance by the resistance of the load by increase the length of the nylon wire. Okay, before this we use the nylon wire 0.6, so we have increased the length into 1.4 millimeter, and then we decrease the diameter for the copper wire. Before this we use the diameter of copper wire is 0.163 millimeter. but this time we increase the diameter into 0.102 copper wire. By doing these two, it will increase the functionality of solar power water heater in the future. So at the end of the experiment, there is no result has obtained due to the short circuit. But from this experiment, a few weaknesses have been observed and improvement for future design have been discussed to design the better functionality of the prototype for net testing. Okay, so this is my Gantt chart references, and I think that's all from me. Thank you.